Okay, so these are our notes for section 5.4. We did jump around a little bit. We are working in chapter 4, but we're going to jump over to this section in chapter 5, and then we're going to skip the rest of chapter 5 for now. But this is something we're going to work on because it's related to ratios, which is what we've been doing a lot of lately with percents. So scale models or scale drawings have what's called a scale factor, and that is this ratio of the model size to the actual size. So let's think about an example. We have a TIE fighter with a 1 to 72 scale factor, and it's a model. Okay, that means 1 inch on the model is the same as 72 inches on the actual TIE fighter. Okay, so the model is an accurate representation, it's just shrunk down. Okay, so again, 1 foot on the model, excuse me, would be 72 feet on the actual model. So I do have a picture of such a thing here, as if people really know what a TIE fighter is. Oh, I just lost it. So 1 second here. Let me pull it back up, and it's pretty cool. So here it is. So here is a 1 to 72. That's not the picture I was looking for. I'm sorry, this is the one I want. 1 to 72 model, scale model of a TIE fighter. So this wing, for example, is 72 times smaller than the wing of an actual TIE fighter. Okay, so it's shrunk down. It's a perfect representation. It's just shrunk down. Okay, so let me get rid of that here, and let's look at a few quick problems. Okay, so here's our TIE fighter. It's 1 to 72 model. So again, it's just a smaller representation, perfect in every way, just smaller. And our scale factor is 1 to 72. So if I have the height of the model's wing is 8 centimeters. I don't know if this is true or not, I just picked those numbers. How tall is the actual wing? Well, we're going to solve this with a proportion. So let's start with the scale factor. So 1 is to 72. So now we got to figure out where the 8 goes. Is the 8 from the actual TIE fighter or from the model? Because in our scale factor here, the model is on top, the actual TIE fighter, the actual thing, is on the bottom. So because this 8 centimeter comes from the model, we're going to put it on top, and I'm going to put an X on the bottom. And we're going to go ahead and solve this. So 1 times X is X, and 8 times 72 is, let me work that out here on the side, 576. Okay? So that means an actual wing of a TIE fighter, again, I have no idea if this is true or not, I just made it up, is 576 centimeters. So that is, if I make that meters, 5.76 meters, and I guess that's, around 17 feet tall or something like that, if that's even true. But hopefully solving it is okay. Set up your scale factor as a fraction, and then make a ratio, a fraction over here, and cross multiply. Okay, so here's another one. Okay, the numbers are the same, but you'll see it's going to be different because of how we set it up. So we'll start with our scale factor, 1 to 72. Okay, so this says the cockpit window is 8 feet in diameter, so that's the actual TIE fighter's window. How big should the window in the model be? So what should the diameter in the model be? Again, the diameter is all the way across the circle going through the center of the circle. So again, I have no idea if this is true, I'm just making it up. But here is the front window of a TIE fighter, and it's 8 feet across. So if we're going to shrink that down for our model, how big do we want that to be? So it's an accurate representation of the real thing. Okay, so again, the numbers are the same, but you'll see they'll go in a different place. The model is on top. Now we want to know how big the window in the model is going to be. We don't know how big the diameter is going to be. So X is going to go on the model part of the fraction on top. And the 8 is going to go on the bottom because that's the actual size. Okay, so we cross multiply. 1 times 8 is 8. X times 72 is 72x. Solve that by dividing by 72. And I get x equals, now this is going to be a decimal here. It's going to be 1/9, which as a decimal is 0.1111 forever. Okay, now that's feet. because those are the units we started with. Now let's make that inches, okay, because then that's a little more meaningful if I say 0.111 feet. Well, how big is that really? So I'm going to multiply that by 12 to get the number of inches, and that is 1.3 inches, or 1.33 forever, but 1.33, or 1 1/3 inches. So that makes a little more sense. So 8 feet on the model is about 1 1/3 inches. I'm sorry, 8 feet on the actual TIE fighter is about 1 1/3 inches on the model. And that keeps the scale right, it keeps it accurate, it's just shrunk down. Okay? So let's look at a couple problems in the book now. I'm just going to kind of show you how to do them. They're pretty straightforward, I think. So these are the exercises in 5.4. Okay, now you're going to need a ruler to do these. So the first few you're going to do have to do with this drawing of a garden bed. We can use scale drawings, we can use scale models. Again, the important part is the scale factor here. And this is really nice because it's down to 1 here. So all we have to do is really just multiply to figure out the actual thing. Okay, now I'm ashamed to admit I don't have a real ruler. I have a protractor here, which is this thing. And you use this to measure angles. We're not going to do that. I'm just going to use this part right here because this is the only centimeter ruler I could find that was accurate. Okay, so number 4 says, what is the actual length of the flower garden? Okay, so let's measure the flower garden. And we'll keep it pretty close here so that we can. It should be a pretty nice answer. And hopefully you can see that it's 5 centimeters. So 1 centimeter is to 5 feet. So 5 centimeters would be to 5 times 5, or 25 feet. Okay, so we're just going to multiply our measurement here by 5 to get the actual number of feet in the garden that would be in our yard or whatever. So if we wanted to find the width, we would just measure the width here. This is 3.5 centimeters. I know that's probably a little hard to see for you, but so we would just do 3.5 times 5 to get the actual number of feet. Okay, so there's a few other problems here, and a lot of people don't really look at paper maps anymore because we have it all on our phone or on a computer and it does it all for us. But maps also have a scale to them. So here's a map of the state of Michigan. And every map, again, we want it to be an accurate representation of the actual area, so we're going to shrink it down and we're going to have a scale factor on there. So here's the scale factor, and this is on every map that you see, at least every accurate map. And it says 1 centimeter on the map is to 50 miles actual distance. Okay, so problem number 8 here says estimate the distance between the cities. Now on a map, you know the roads curve, and it's not a perfect measurement, right? Because it's really hard to measure all these little curves in a road, but you get a general picture. Most maps actually have numbers printed on them to give you the actual mileage, but let's say you don't have that and you want to figure out. So we want to go from Kalamazoo, which is right here, to Ann Arbor. So again, if you look at this map, it's got all kinds of little curves in it, but we're just going to do our best to estimate it. We're going to measure. So from Kalamazoo to Ann Arbor, oops, I'm upside down, is 2 centimeters. Again, hopefully you can see that. So this tells us 1 centimeter is to 50 miles, so that means 2 centimeters is to 2 times 50, or 100 miles. So therefore it's about 100 miles from Kalamazoo to Ann Arbor. I would guess, based on all these little curves, that it's probably a little bit farther, but in any case that's a really good estimate, and you just use a ruler to measure the distance, and then in this case you'll multiply that answer by 50. Okay, so I hope that's enough to get you started with section 5.4. Again, you'll need a centimeter ruler to measure the problems in the book, so hopefully you've got one laying around the house somewhere. And again, if you have any questions whatsoever, please don't hesitate to let me know. Thank you.